So this image, the cover of the August 1981 Byte Smalltalk issue, is an image that's known very well throughout the Smalltalk community. It's the origin of the balloon as the symbol for Smalltalk. It's the first place it appeared. And but I ran across my issue of Byte. I knew I had it, but I didn't know where. And I ran across it about a year ago and started looking through it and realized there was a bunch of cool stuff in there. So I decided it would be kind of fun to do a talk about that issue and what was actually in it and what we might learn from that yet today and what's still valid and what isn't. But I found that it was very difficult to actually tell the story of the Byte issue without putting it in the context of my life and what it meant to me and my path towards Smalltalk. So in order to do that, we're going to have to take a flashback starting in 1968 and look at a few other documents that were influential in my life, although we're going to spend most of our time on the 1981 Byte issue. So the first thing is that in 1968, computers were not common. Most people had never seen one, let alone used one. So this is what the public's impression of computers was. It mostly came from cartoons. This cartoon happens to be for a scientific magazine, a magazine for scientists, many of whom had actually used computers. Therefore, this is a much more accurate representation than most of the cartoons of the era. For those of you in the back who can't read it, the caption is, and in 1/10,000th of a second, it can compound the programmer's error 87,500 times. Now, we know that this is very inaccurate. Computers weren't that fast until quite recently. And back then, this is what computers looked like when you did see one. And I did see one. I lived in Phoenix at the time. And I lived near the center of town. And just down the street, there was a large bank. And I would go down there, and behind the glass in the air-conditioned room, there was something much like this. And I would look at it and watch its tapes spin and have no idea what it was really doing. Nobody could really explain that to me that I knew. And then, for my birthday that year in 1968, my father gave me this book, How to Build a Working Digital Computer. And yes, that is a core memory unit, 5 4-bit words on the cover made out of paper clips. So besides paper clips,
how many did you build?
We mass-produced those. We sold about $5 million. Unfortunately, we mispriced our supply chain, and I lost all the money I made out of that. The ALU was made out of knife switches, 4-bit machine. The drum memory was a sheet of paper that you wrapped around the juice can and you cut holes in it, and that's how you programmed the machine. Cool. But the concepts were actually valid. And this is a piece of the preliminary listing for a 4x4 multiply, which is just about as big a program as the machine could handle. And this is the preliminary copy because they showed you the mistakes and then there were corrections to them afterwards. And then they gave you the real listing, so they showed you debugging. So this was a lot valid. And now I kind of understood, what these computers were actually doing, I thought. And so then, at least I understood how to multiply two 4-bit numbers. And then, shortly thereafter, my mother, who was working in a clerical job at the DeVry Technical Institute here in Phoenix, they decided to teach all of their employees how to program in BASIC on an interactive teletype terminal. And so she would go to these programming classes in the evening, and she would bring home her listings. And I would look at that, and one of the things they did was they would have her type in a hello world program, and she's at the teletype, typing it in. And then they say, well, okay, now run your program. Just type RUN. And so she typed RUN. And everyone got a good laugh out of that, and my mother never really did learn how to program. But she brought home the listings to me, and I read this, and I could immediately see pretty much what it was trying to do. And it totally blew my mind because I had no idea that higher level languages existed. I thought you programmed by cutting holes in, I understood that for knife switches you could substitute these things I dimly understood called transistors and things like that. So I never actually built that manual machine. But the idea of higher level languages had never occurred to me. So this was just like, how do they do that? So
This was a mystical message to you, Martin. Are you in?
How old were you when you first saw that?
This is 12 years old, 12 or 13 years old. So fast forward to 1975, I am a freshman in computer science at university. And so I'm using punch cards and interactive terminals when I can get them to program in Fortran and BASIC. And somebody loans me this book.
Yes!
Ted Nelson's
Yes.
Computer Lib Dream Machines.
Yes!
And this book is, it's one book on one side and the other book on the other side.
Oh, yeah.
And in Computer Lib, and I have a copy of this now, I bought my own copy later. And Computer Lib, you can and must understand computers now. In that, Ted Nelson talks about, he tries to explain to lay people how programs work, or how computers work, and he tells them, just try stuff. Learn these programming languages. Here's 3 languages to get you started. BASIC, your first computer language. Track, the sleeping giant. And APL, stark and clever, to use his words. He also rails against what he calls cyber crud. Putting things over on people using computers. Now, there's a lot more knowledge about computers in the world now than there was then, so computer crud or cyber crud has changed its nature somewhat, but it's still out there, unfortunately. But I got most of my inspiration from the other half of the book. This is Dream Machines, New Freedoms Through Computer Screens. This is all about interactivity and graphics and animation and really cool stuff that no one had ever heard of when this book was written in 1973.
They're really tiny machines that fit in a room.
Yeah, exactly, like that, tiny machines that fit in a room. And I can't begin to show you all the things, but it just blew my mind again. Some of the things, if computers are the way of the future, displays are the surfboards. He had, of course, had no layout software to do this. This is largely handwritten and hand-typed and laid out in big boards on his living room floor, from what I hear. If the computer is a universal control system, let's give kids universes to control. That's kind of synchronizing with, at the time he wrote that, I don't think he'd heard of what was going on at Park, but he was thinking along some of the same lines. He also talked about hypertext, which is a word he invented back in the 60s, and more or less predicted, although he is not at all happy from what I hear about the way that the web has turned out. He's not alone in that. But he had this idea of hooking things together in various ways, because you can't, the world is not in a hierarchical organization, for instance. Everything is deeply intertwined, one of his favorite sayings. But the thing that's most appropriate to this talk is that this was I got handed this in late August of 1975, and it had this special supplement to the 3rd printing, August 1975. It was hot off the presses. And in this, he added stuff about what had happened in the 2 years since he'd originally written the book. And one of the things that he had was he documented his visit to Park. And in there, he says, this is obviously the place to tell you about Alan Kay and the Dynabook. And he goes on and talks about that a little bit. If you're into computers, they'll show you how all this is run by the beautiful Smalltalk language, which any bright child can learn, which has some awfully powerful features. Now, this was the first place I'd ever heard of Smalltalk, and that's all he says about Smalltalk. For some reason, though, that stuck in my head, because he was talking about all this really neat stuff, and he said that this was really neat, so it stuck in my head. But I didn't really hear anything more about Smalltalk for a couple of more years, until in 1977, when I ran across this article in Computer Magazine, March issue, Personal Dynamic Media, that Alan Adele wrote. And in that, they talk about all the cool stuff that they were doing with kids in Smalltalk 72 primarily. And they were doing 2D graphics, and they were doing 3D graphics, and they were doing musical notation and music. And this 15-year-old had created this schematic editing program. And I went, this is amazing that you can do all this stuff and all these graphics displays, and this is the stuff that Ted Nelson was talking about and the stuff that I really want to do. And I'm going, now how do you do this? What is this magical Smalltalk language that they're talking about, but not telling me anything about? And they had one figure that had this screen full of Smalltalk 72. And I looked at this with my lovely computer, with my lovely computer science education in, PL1, and this was total Greek. I mean, what is this? I cannot understand this at all. At the end of the article, there was a bibliography which referenced the Smalltalk 72 instruction manual with a technical report number from Park. And so after stewing about this for about 6 to 9 months, I got up the nerve to actually call Park and attempt to order a copy of the Smalltalk 72 instruction manual so I could get some idea of what was going on. And the publications department said, well, I'm sorry, that has been withdrawn from publication. It's no longer available. This was in about probably January, February of 1978. And I said, well, do you have anything about Smalltalk, anything at all? And he said, well, would you like to talk to someone in the learning research group? And I said, oh, I guess so. I was very shy in those days. And about 15 seconds later, I'm on the phone with Adele, who says, no, Alan withdrew that book because it was so out of date with what we're doing now, which, later I found out was totally true. But she said, really, there isn't anything available about Smalltalk now. We're trying to get the word out, but, there's nothing available right now. So I said, well, okay. So now I go into this period of waiting.
She wouldn't send you a copy?
No. I have a copy now. I downloaded it off the Viewpoints site just a year ago.
But you talked to Adele.
I did talk to Adele. Adele really, honestly, was a person that could be talked to.
Yes.
I have the evidence. So now during this time when I was just sitting around waiting, things were happening. As we've heard in some of the other talks, through 1979, 1980, they were working with Xerox on how to get this out and that they could release it in various things. And they finally decided they were going to release it in 3 phases. There was going to be a series of articles about Smalltalk that would be shown to the public, and then there would be a book about Smalltalk, and then the code itself would be put out in some form. And the first phase of that was the articles. So one day in 1981, this arrives in my mailbox. This is a scan of the beat-up cover of my copy of the Byte magazine, which I do still have, although it's in 2 pieces because the binding glue gave up in the process of preparing this talk and scanning various pages out of it. But it is otherwise complete. And this is a 480-page article that has, and I know you can't read this, this table of contents, but there are 15 feature articles, 13 of which are about Smalltalk. So they devoted the bulk of the editorial content of a 480-page issue to Smalltalk. It was quite remarkable. But now that we're in 1981, let's take a quick look at what some of the rest of the magazine that isn't Smalltalk, just to get an idea of the context of what computing was like in 1981. This is a laptop.
It's an interim Dynabook.
This is your interim Wi-Fi. It's wireless computing because it's an acoustic coupler. This is the internet. This is you notice that you can get information about their books by dialing a long distance number, and you can't even get through on a modem during the day and the week because nobody's going to pay for that. So it's up during nights and weekends only. So that's networking. It's still considered reasonable to buy a full-color ad, full-page ad in Byte magazine, marketing to people that are still using audio cassettes as their mass storage medium and that might want to move up. This is the hard disk you've been waiting for. That's about $8,000 in today's dollars for a 10 megabyte hard disk. And that was, we had been waiting because before that we couldn't get any hard disks at all. This is an ad for Popular Computing Magazine, which is a new magazine just coming out, and it is being marketed as the answer to computer phobia. So still, computers are just still getting out into the world. Another thing that is there is this was the only ad from Microsoft in the entire magazine. Now, Microsoft is a company that they're the people that make the floating point BASIC for the Apple II. That's what they're mainly known for at this point. This happens to be a hardware add-in for the Apple II that gives it a Z80 processor and you can run CPM on it. And that's, those are the two leading operating systems of the day, the Apple II OS, and if it can be called an OS, and CPM. And so it's into this world that we drop Smalltalk, which is going to be rather different. I mean, certainly some people in some circles know about Smalltalk and have seen some things like that, but the readers of Byte have not. And they're used to these little tiny computers that you do BASIC on. So here's the introduction by the editor, a language from the 1980s. And down here, he has to explain what a mouse is, because nobody else has seen one. A small mechanical box with wheels that let you quickly move the cursor around the screen. So I'm going to talk about each of the articles, and in some in more depth than others. And it's a little intimidating, given that one of the authors is in the room, but and comments will be welcome in that. We'll see how good I get it. But Adele Goldberg wrote this, introducing the Smalltalk 80 system, explained why they'd chosen the balloon and what the meaning of that was. And if you don't know the story behind that, the last time I gave this talk last summer in Europe, I said, ask me afterwards. This time I will say, ask Dan, because he's actually the origin of that. And there's a few interesting things here, these diagrams that were done. And this is the wizard on his computational cloud. He builds a Taj Mahal, which is a programming language and environment, which the developer then uses to build a bridge for the users to walk across. Now, this is the conventional model of programming, because the users have to walk over whatever bridge the developer chooses to build. So one of the goals of Smalltalk was to change things so that they build the Taj Mahal so that it's really easy for the developer to build application kits, which the user can then use to build a bridge that meets their needs. Also, this diagram shows the developer modifying his own Taj Mahal, which is pretty neat. And then they have this diagram about the kit maker being built into the Taj Mahal. I'm not sure that that goal was ever quite fully realized, at least not the way I understood it from the text. And finally, the programmer using the Taj Mahal to build his own computational cloud from which to do whatever the heck he wants, exploring new metaphors, that sort of thing, which is sort of what I'm doing with the MIST project, which I'll be talking about tomorrow afternoon. Various staff and in the Learning Research Group wrote the article about the Smalltalk 80 system. This is mostly concerned with the syntax of Smalltalk, which I assume you already know, so I'm going to move on to David Robson's article on object-oriented software systems, basically a description of what object orientation is for people that have never heard of it before. There's a couple of interesting comments in here. He leads with, many people who have no idea how a computer works find the idea of object-oriented systems quite natural. In contrast, people who have experience with computers think this is strange. That's probably still true. Larry Tesler wrote an article about the Smalltalk environment. This is the Don't Mode Me In that I heard you talking about before, with his famous Don't Mode Me In t-shirt. And he talks in this article about about how they came, he and various other staff members came up with the rules for how you actually interact with text on a bitmap display. And these rules are still in force universally. You select characters and whatever you type replaces the selection, so on like that. That was new then. No one had ever seen that. It was subscribed to this magazine. And he concludes, he talks about type checking. Important in most systems for 4 reasons, none of which is very important in Smalltalk. So, goodbye static typing. Okay. Trygve Rinskog from Norway wrote User-Oriented Descriptions of Smalltalk Systems, which is about documentation of systems. And more than 20 years of experience has shown us that a bad system design can never be hidden from the user, even by a masterfully devised user interface. I think that's a very good thing to keep remembering. And he concludes by saying, much experimenting needs to be done before we can learn how to make systems that are self-documenting on any level. That's probably still very unfortunately true, even more than 30 years later. Dan Ingalls wrote a Smalltalk graphics kernel article, which shows some nice examples of how BitBlip, composes characters on the screen by copying from one bitmap to another. James Althoff Jr. talks about data structures, how you take familiar data structures and what does that going to look like in an object world. Like for instance, here's how to build a singly linked list, and what does that look like in objects, and what do the methods look like, that sort of thing. Conclusion is the class construct is an extremely useful tool for implementing data structures. I certainly have found that true in all the time I've been using Smalltalk. And another Dan Engel's article, Design Principles Behind Smalltalk. We saw a lot about that in the, in the keynote this morning. But I'm going to actually dive a little more into this and look at each of the major points. And so personal mastery. If the system is to serve the creative spirit, it must be entirely comprehensible to a single individual. That's a pretty neat goal. I like it. Good design. Have a minimum set of unchangeable parts so that you can change anything you need to, except for those few. Make those parts as general as possible. All parts of the system should be held in a uniform framework. Purpose of language, to provide a framework for communication. This is talking about language in general, not computer language specifically. But then he goes on, and for instance, this is the diagram for, if you want to get ideas across from mind to mind, you're stuck with translating through the body and its senses and its affordances. So you have to do this path. And similarly, with computer communication, you end up dealing with the limitations of the keyboard and the mouse and the display, and then going to, for person-computer communication. Scope. Design of a language needs to deal with internal models, external media, and the interaction between both. That's the more specific computer-human communication. Objects. A language should support the concept of object, provide a uniform means for referring to the objects. Storage management must provide automatic storage management to be object-oriented. Because code sprinkled with storage management is not well matched to humans. This is once again that readability, the code, coder as reader thing. Messages. Computing should be viewed as an intrinsic capability of objects that can be uniformly invoked by sending messages. So, in other words, you don't compute on an object, the object computes when you send it a message. This is, if anything, is the key principle in object-oriented programming. I think that's it. A uniform metaphor. The language should be designed around a powerful metaphor that can be uniformly applied in all areas. Unfortunately, my metaphor for translating pages to slides broke down in this particular case because of the column break. So I don't have a uniform metaphor there, but that's certainly a good thing to know about. Modularity. Don't depend on the internal details of other components. This is encapsulation, and it helps you to manage complexity. Certainly true. Classification. Classify similar objects and be able to add new classes on an equal footing with the kernel classes. This is a key thing that attracted me to Smalltalk. Before I was able to run Smalltalk, I used Forth, and that was one of the things I liked about Forth was that the code you add and the code that came with it are exactly on an equal footing. It's a very, very nice way to work. Polymorphism. Don't worry about the insides, just the behavior. Factoring. Each component should appear in only one place. This would be similarly stated as once and only once as part of extreme programming creed years later. And Dan also talks in the article about how Smalltalk encourages factoring by providing inheritance as a mechanism. Leverage. When a system is well factored, great leverage is available to users and implementers alike. So, if you inherit from something, then in the base class that is inherited from, if you make a change there, then it automatically propagates to everything else, and you've made a powerful change with a very small change to code. Virtual machine. A virtual machine specification establishes a framework for application of technology. The arguments here involve performance, but also a well-defined interface. And I think that's a really useful thing to have, a well-defined interface, although you'll see in my talk tomorrow that I'm working on building something that doesn't have a virtual machine at all because I want to get rid of that. But the well-defined interface thing is a really good idea. reactive principle. Every component accessible to the user should be able to present itself in a meaningful way for observation and manipulation. And for end users, that's certainly a really good thing to have. For developers, it's also a good thing to have, even if it's something like an inspector, which really gives you a handle on an object that lets you just see what that thing is and to interact with that individual object directly. Operating system. An operating system is a collection of things that don't fit into a language. There shouldn't be one. I personally want to extend that to virtual machines as well. Virtual machine is a collection of things that don't fit into the language, and there shouldn't be one of those either. But I like the well-defined interface. And natural selection. Languages and systems that are of sound design will persist to be supplanted only by better ones. This may be a little optimistic. But supplanted, you know, it depends on what you mean by supplanted. There is the fact that we are here 32 years later talking about this. So Smalltalk definitely has survived and thrived, although inferior things have also thrived. So that was a great article.
In the long view, it depends on applying that to the people too.
Right. Yes. So Glenn Krasner wrote about the virtual machine and talked about how it consisted of a storage manager here with object table or logical translation of object pointers to physical locations in memory. The storage manager, the bytecode interpreter, the primitive methods. Let's move on. Control structures. Peter Deutsch wrote this article about control structures, and here, this is some of the examples of some of the weirdest, freakiest things you can do in Smalltalk that were covered in the byte issue. Talks about the block. And so here he builds a case statement out of blocks by defining case as, on array. You give it a case method, and then you can have a case statement. And he also talks about how, well, if you then define a comma method on enough things and do this and that, you can actually get the syntax down to be something kind of interesting. But then he kind of backs off and says, well, but that may not be a good idea. You don't want to mess with things too much. This may or may not have been developing on some of the experience with Smalltalk 72, where things were able to be customized so much that they made programs unreadable, which is sort of the downside to domain-specific languages. It's like if you make a domain-specific language at a very small granularity of domain, you end up with a zillion domain-specific languages, and you have to learn them all to read the code. So, and then this interesting thing, which is a loop with an exit. This routine goes through and tries to find the highest value in an array, but if you hit 1,000 or greater, then stop. You're good, and just return that value. So there's a loop going through and looking at it, and you get this loop with exit, and then it returns. And this is a neat trick using non-local return to do it. And so, and he talks about dynamic binding, where the variable is bound for the duration of the block. And then he also talks about coroutines, and then it does some stuff with multi-threading and with process and with semaphore and some of the more advanced things than most of the other articles in this issue. Stuff that I didn't really understand. There wasn't quite enough information in this byte issue for me to really understand all of this stuff. But he concludes by saying the existence of blocks and the simple notation for writing them is really cool and makes it very powerful. The ability to manipulate the control state directly and the accessibility of the entire system to modification, these are the things that make it really powerful and cool. Adele Goldberg and Joan Ross ask, is the Smalltalk 80 for system or for children? And the answer is basically, we did all of our testing with children, but really it's designed for everybody. But in there they talk primarily by using this example of the dance talk kit, where you could make figures that danced and teach them dances and that sort of thing. There's a little bit of common DNA with eToys, I think, in that, certainly conceptually. William Bowman and Bob Flegel do Toolbox, and And William Bowman's an artist, and Bob Plagel's a computer scientist, and they wanted to get together and make a good drawing tool for illustrating. They talk about how typical computer art of the time was very mathematical in nature, but this is an example. But they wanted to be able to do things like this illustration that William Bowman did on the toolbox that they created in Smalltalk. And another artist did some portraits and things like that were listed in the article. Ted Kaler wrote a virtual memory article. This is a documentation of the OOZ system for Smalltalk 76. They talk about how it isn't applicable to Smalltalk 80. The loom system for Smalltalk 80, I guess, was not ready in time to get into this article, but was later documented in the Green Book. And here they give a little bit of the how this is translated. The main thing about this was that it's instead of paging out to virtual memory by pages, it swaps in and out object by object. And they give the details of how that works and this diagram. One of the things I like about this particular diagram is the quantities. Main memory is 50 to 100K bytes, and secondary storage is 5 to 10 megabytes.
Why would you need any more?
I don't know. So that's it for the Smalltalk articles in the byte issue. There's a couple of other things that were in there that might be interesting. There was this rumor, for instance, IBM is said to be developing an under $5,000 small business system aimed at competing with the other personal computers of the day. Now this rumor turned out to be true. In fact, this issue may have still been on the stands of some of the news agents that were a little slow changing out their stock, because it was in late August of 1981 that the IBM PC was introduced, announced to the world. And in doing so, I don't think IBM really knew this, but they were, in doing that, they handed their hardware crown to Intel and their software crown to Microsoft. Fortunately, they survived. And also, the IEEE standard for the S100 bus was finally out of committee to be made obsolete by the thing I just mentioned. So what about what happened after 1981? Well, in 1982, the company that would become Gemstone is founded. In 1983, finally, I walk into a bookstore and see this, and immediately grab it, and take it, and read it, and fall asleep reading it, and read it again, until I think I really understand the entire thing. That diagram of how classes and meta-classes interact. It took a few readings, but once I had that, and then the section 4, read that a couple times, and then I go, oh, I get it. I really understand this. Now I want to use it. And later that year, the Green Book came out, and in 1984, the Orange Book came out, and the Red Book, which I'm told was planned and was to be about MVC, never came out because I heard that they believed that MVC was becoming obsolete at that point. That wasn't quite the right model, the way it was organized. And it's kind of interesting that everyone claims to be MVC if they want to be cool now. So I had that, but it wasn't until 1985 that I actually got my hands on a running copy. I had a Macintosh. I bought it in 1984 because at least then I had bitmap graphics and a mouse. So I scraped together all the money I had and I bought that. And then in 1985, Apta Smalltalk became available, and I immediately sent my $75 or $50, whichever it was, for that first version, and immediately founded a Smalltalk user group in Minneapolis. And the first meeting of the Smalltalk users group, there were 5 of us in my living room. None of us had ever run Smalltalk because my Apta Smalltalk disks had not yet arrived, so none of us had run Smalltalk. We sat around and talked about Smalltalk. Now, at the next month's meeting, I was the old pro because I had actually had Apta Smalltalk for 3 weeks, and without tutoring, had been running it and looking at the code and trying to figure out what I was doing.
You were running the virtual machine in your head.
That's right. It's that probably does break all the previously mentioned records in this conference for the slowest. And I wrote, and my first Smalltalk program did not look like a Smalltalk program, so I wrote it, 3 times until it started looking like the code I found in the image, which was the best teaching tool I ever found. Really. I mean, years later, all the books on OO design, those were all good, but really the code in the image taught me more than anything else about Smalltalk. So we can fast forward to 1994. I finally became up to this time I'd been doing hardware and software design. I was a one-man shop. I would basically design little devices for people that had microcomputers in them, and then I would program them in Forth and let them go off and manufacture how many of them they needed. And in 1994, I kind of said, you know, the hardware world and the software world are both just changing so fast. It's so hard to keep up. I cannot continue to do a good job with both of these. I'm going to have to choose hardware or software. And this was a hard choice for me. I really enjoyed doing both. And then I said to myself, you know, the most fun I've ever had is programming in Smalltalk. If I can be a Smalltalk programmer, I will choose software. And I did, and I got a full-time job programming in Smalltalk, and that's what I have been doing ever since. In 1996, I moved to Oregon and got a job with Gemstone Systems, and been there ever since. And here I am today, still programming in Smalltalk, still having a great time, and not about to stop anytime soon. So that's my past and present. The future is mostly tomorrow's talk. So before I close, open up for questions. There's a couple of things that I want as the takeaways for this talk about all of this story. So just remember these things. So use the Taj Mahal of Smalltalk to build your dreams. Smalltalk's not just a great platform to develop all kinds of stuff. It also has a special place in the history of computing. And Smalltalk's not just a special part of my personal history, it's part of your history as well. And history doesn't stop here. Go out, make history. Thank you. And we have a few minutes for questions, if there are any.
I don't have a question,
Yes.
but a consideration. I live in Italy, and I was a subscriber of Byte. I supposed to be one of the probably 10s that received Byte at that time in Italy. And I read, I was a subscriber probably from 2 years, and because I remember also the fourth magazine, and I remember the fourth was really clear. When I read that Byte, I understood everything. I was working on the forward side of the PDP. And when I read the Byte magazine, I remember that I didn't understand nothing. And for a long time, I've been sure to be completely fooled. Up to this year when I discovered that most of the people I know and that I consider nice guys that didn't understand nothing reading the Byte magazine. And they took a lot of time to understand what it was written. So I go back home and I feel much better. I'm quite happy about myself. Yeah.
Yes. Yeah, the Byte magazine it did give the flavor.
Yeah.
Yeah.
It wasn't for me. It wasn't until the Blue Book that I really felt I understood it.
I never saw the Blue Book until later. We started in Italy with the digital. On the Byte magazine, we saw the advertising about the method, and we bought, but it never ran. So we bought the digital first edition with a colleague at the university, and we started playing with that. And that's where we started understanding something. But the first book I saw was the digital book that was together with the product. So.
Well, they announced the Blue Book in that, because I know when I got my August issue, I always loved the August issue because it was a language issue.
Yeah.
I got mine, I just had decided to bail out of graduate school and was gonna take a job programming.
Yeah.
And then I saw this and it was like, oh my God, it's like category theory, but you can touch it. And I saw the listing and I immediately put in an advance order for the Blue Book whenever it shipped.
Yeah.
And then had to get another one because the binding, broke
Yeah.
after about the second week.
Yeah, I do have. Yeah, exactly. I do have 2 copies. After we moved to Oregon, my wife happened to see the Blue Book for sale for $3 at a used book sale, and she's smart enough to say Martin is going to want that. So.
You were smart enough to marry a woman that understands that.
Yes. Yes, well, she put up with me talking about Smalltalk without knowing anything about it to her for years until I actually got my hands on it. So,
Yeah, I retained her as a consultant to the company. True story.
Yeah.
I had a friend from Pug who was really confused while I was keep talking about small. Got my hands on Well, what can it do that Pascal can't do? It's like, well, okay.
Right. I can tell you a story of how Smalltalk got some traction in Ontario, and at the time I was working for PDS. This was '93, and I had taken Smalltalk as part of a night school AI class in '90, '91, '92 timeframe. And they had sent out a newsletter saying that they were looking, using Smalltalk to do the assembly line automation. And it was like an interesting project. So I emailed the guy saying, this is interesting, I'm interested, you know, I know some Smalltalk, I'm kind of interested in this. He calls me up and says, you know Smalltalk? I said, yeah. And a week later, I was on the team. I was the only person who knew anything about it. It was basically one of those, hey, this is a magic bullet kind of thing, sent it to me. They had set up a couple of Unix servers to get it up. We got VW in. So they finally get it fired up, and the guy walks over and says, show me some code. And I'm like, okay, I'm really, so I think I did something like, you know, transcript show hello world.
Yeah.
But that's, so people, and they ultimately figured out that they had made a wrong technical choice a few months later, but it was Smalltalk, gotta use it. And so EDS brought it in for that reason.
Nice. Cool. All right, well, it's getting to be just a couple of minutes until the next talk starts, and there's no talk in this room next, only in the larger room. So we should probably migrate our way over there now. Thank you all very much.
I'm profoundly